Hello everyone, welcome to Brain Blitz Audios. Now, in this week, the Kerala Engineering, Architecture and Medical Entrance examinations dates were released. So this exam is scheduled to be held on July the 24th of this year. And so therefore, students have a hard time to study a lot of topics within a span of just 1 month. So today, this video is dedicated to, explaining the previous year questions asked in the same examination. So this is a new segment called Keam Prep. So today we're going to be looking at some questions from the 2016 edition of KEAM. So what we're going to do is we're going to explain these questions and then find out the solution to those questions. Let's start off with a question from mathematics. If star is the operation defined as a star b equals a to the power b for a and b belonging to n, then 2 star 3, which is placed inside a bracket, and then the bracket star 2 is equal to. So we need to find out the correct value for this particular operation. So what do we know? We know that when a is starred with b, then the value is equal to a raised to b. So that means 2 star 3 will be equal to 2 to the power of 3, that is 2 cubed. Now, in this particular question, we have 2 star 3, and then that, operation, the product of that operation is starred with 2. So essentially what we're going to do here is we are going to write 2 cube inside the bracket and then starred with 2. And everybody knows that 2 times 2 times 2 equals 8, so 2 cube is 8. And then 8 starred with 2 means 8 squared will be the value of 2 starred 3 inside the bracket and then starred 2 outside the bracket. So 8 squared, that is 8 times 8, is equal to 64. So therefore, option D, 64, is the correct answer to this question. So basically, the idea is to use the operation first inside the bracket and then outside. So what we're doing is BODMAS, the BODMAS rule. So first we attack the bracket, then we attack the multiplication. That means multiplication, then we do division, and then multiplication that's outside the bracket, and finally addition and subtraction. Division, multiplication, and addition, subtraction can be interchanged with each other. So now that we know how we can solve this question, let's look at another example on how to solve questions. The domain of the function fx equals x squared minus 9 divided by x minus 3 if x is not equal to 3, and 6 if x is equal to 3 is. So we need to find a domain of this function. 0 to 3, open interval 0 to 3, open interval minus infinity to 3, open interval minus infinity to infinity, open interval 3 to infinity, open interval minus 3 to 3. So how do we solve this question? You can see that the function has 2 parts. If x is equal to 3, the value of the function is 6. So f of 3 equals 6. Also, we know that if x is not equal to 3, then the value of f of x is determined by x squared minus 9 divided by x minus 3. So this is a function that we usually find in questions on continuity. So what we essentially want to find out is to determine whether the function here is continuous. So at x equals 3, let's find out the left-hand limit. So the left-hand limit will be limit x tends to 3 minus, then we put in the function if x is not equal to 3. So that is x squared minus 9 divided by x minus 3. So now you can see that the numerator is basically difference in squares. So we can factorize the numerator to x minus 3 times x plus 3. And the denominator has an x minus 3. So therefore, those two get cancelled, and finally you get limit x tends to 3 minus x plus 3. Now when we apply the limit, we essentially put x equals 3, so 3 plus 3 equals 6. Now let's look at the right-hand limit. The right-hand limit is limit x tends to 3 plus, so for values above 3, the function will be x squared minus 9 divided by x minus 3. So now we use the same trick again, since we have the same function. So difference in squares, we factorize it as x plus 3 times x minus 3. And then the denominator is x minus 3. Cancel them out. The right-hand side now, the right-hand limit now becomes limit x tends to 3 plus x plus 3. We just put the value of 3 here, so that's 3 plus 3, which is equal to 6. So now we know that the left-hand limit is equal to 6, the right-hand limit is equal to 6, and also f of 3 is equal to 6. So the equation of continuity, so which is left-hand limit equals right-hand limit equals f of a, so that is satisfied here. So therefore, since f of x is continuous, it means that there is no value of x in the interval minus infinity to infinity where f of x does not exist. So therefore, that indirectly tells you that the domain of f of x will be the set of real numbers, that is open interval minus infinity to infinity. So therefore, if we look at the following options, you can see that option C, minus infinity to infinity, will be the correct option. So in order to solve questions like these, the first thing to do is to find out whether they are continuous or not. And once you know that they're continuous, then the domain will be the set of real numbers, that is from minus infinity to infinity. And all the other options here are incorrect because these occur when the function is discontinuous, which is not true here. So the function here is not discontinuous. It is continuous. So therefore, its domain will be from minus infinity to infinity. And the interval is an open interval. That means minus infinity and infinity are not part of the function. Every other element is. Now let's look at some questions of chemistry. CH3CH double bond with CH2. Now this is what we call butene. It's an alkene. That means it has a double bond. It's an organic compound. It reacts readily with B2H6, which is what we call diborane. It's basically a dimer of BH3. So butene reacts readily with diborane, and the product on oxidation with alkaline H2O2 gives. Does it give a secondary alcohol? Does it give you a ketone? Does it give you a primary alcohol? Does it give you an aldehyde? Or does it give you an aldehyde with 4 carbons? So let's write down the equation here. So we have CH3, CH double bond with CH2. And now this reacts with diborane, B2H6, and the reaction is in the presence of H2O2. Now this reaction is what we know as hydroboration oxidation. And hydroboration oxidation means that butene gets oxidized into an alcohol or an aldehyde. So it goes into an alcohol group or a carbonyl group. Now notice that the product on oxidation with alkaline H2O2 gives. Now, when you're talking about oxidation with H2O2, that is quite special. The reason being, it follows the anti-Markovnikov rule. So basically, the Markovnikov rule states that if you are, reacting something, if you're oxidizing a particular organic compound with water, then the double bond will break and the hydrogen will go into the area which has more hydrogen, and the OH group will move to the other end. So that means in normal Markovnikov rule, butene will transform to butanol. It's actually propane. So propene reacting with diborane, so that gives you 2 propan-2-ol. So in this case, it's quite the opposite. So the anti-Markovnikov rule occurs when you have H2O2, when the product is on oxidation with alkaline H2O2. So in this particular case, what happens is that the OH group moves towards the area with more hydrogen, and the H group moves towards the area with less hydrogen. So therefore, CH3, CH double bond CH2 now becomes CH3, CH2, CH2, OH. So this is the final product that we get. And among the following options, it is clear that option C is the correct option. So in hydroboration oxidation, it's alcohol. So options B, D, and E are incorrect. And since we are using the anti-Markovnikov rule, the OH group goes towards the area with more hydrogen, towards the carbon with more hydrogen. So therefore, option A is incorrect because it shows that OH goes on both sides, which is not true. So option C, CH3, CH2, CH2OH is the correct answer. Now, if you want to know what the name of this particular compound is, it's propanol. So it's a type of alcohol with 3 carbon atoms in it. Let's look at another question of chemistry. Which one of the following exhibits positive resonance effect, also known as the +R effect? Is it an aldehyde group? Is it a cyanide group? Is it a carboxylic acid? Is it an acetic anhydride? Or is it an NO2 group? So, in order to understand which of these exhibit +R effect, we need to know when +R effect occurs. Now, +R effect, or positive resonance, is shown by electron releasing group, what we call ERG in short. And these electron releasing groups are normally ortho para directors in aromatic compounds. So in order to find out which of the following exhibits positive resonance effect, all we have to do is find out which among the following is an electron releasing group. So when you release an electron, the charge moves towards the ring, and then from the ring it moves on and shows resonance. So that's what we call positive resonance. When you have negative resonance, that's -R effect, then the electron is taken from the ring, and then that sets off a negative resonance all over the organic compound, all over the aromatic compound. So CHO, this is aldehydic group, and aldehydic group is an electron withdrawing group. So that means it exhibits the -R effect. So option A is incorrect. What about option B, cyanide? Well, cyanide also withdraws electrons, so that means it has the -R effect. Carboxylic acid is also the same thing, -R effect. And NO2 also exhibits electron withdrawing groups, so -R effect. Now, OCOR, which stands for acetic anhydride, is an electron releasing group because, R, that is the part that has the hydrocarbon chain, it donates electrons, and then these electrons are transferred to the organic compound, so that means that it exhibits a positive resonance. So therefore, OCOR is acetic anhydride is an electron releasing group, so therefore it shows the plus R effect. So that means option D, OCOR, is the correct answer. Now, let's look at some questions of physics. The vertical component of the Earth's magnetic field is 1 by root 3 times the horizontal component at a certain place. The angle of dip at that particular place is 90 degrees, 45 degrees, 0 degrees, 60 degrees, 30 degrees. So this is a question from magnetism and matter. So this is the lesson that we study in grade 12. Now, if you are confused about what are the syllabi that come for these various entrance examinations, they're usually from your higher secondary education, and we at Brain Blitz Audios have created a lot of mind maps for easy revision of these chapters. More about it at the end. So, in this particular scenario for magnetism and matter, we know that the vertical component of the Earth's magnetic field is 1 by root 3 times the horizontal component. So if we take the horizontal component to the left-hand side, it will be BV divided by BH. That is equal to 1 by root 3. Now, the vertical component divided by the horizontal component, it's basically B sine theta divided by B cos theta. So that means you have not sine theta, actually, it's sine delta. So B sine delta divided by B cos delta equals sine delta by cos delta, which is equal to tan delta, where delta is the angle of dip. So tan delta is equal to 1 by root 3. Now, if you have learned your tangents from grade 10, you would know that 1 by root 3 is equal to tan of 30 degrees. So that means the value of the angle of dip and that particular place is 30 degrees. So therefore, option E, 30 degrees, is correct. All the other angles are incorrect, because if it was 90 degrees, then tan 90 would be, well, infinite, which is not possible. Tan 45 would have been 1, which is not correct. Tan 0 would have been 0, and tan 60 would have been root 3 instead of 1 by root 3, which is for tan 30. So therefore, option E, 30 degrees, is the correct answer. Here is the final question for this particular episode. This is again from physics. The magnetic field at any point on the axial line of a short bar magnet at a distance r from its center is proportional to r 1 by r 1 by r squared, r cubed 1 by r cubed. So how do we solve this question? This question is again from magnetism and matter. So this question requires us to know the formula for magnetic induction. So magnetic induction at a point on the axis of a bar magnet at a distance r. So the value here will be B equals mu naught divided by 4 pi, which is the constant here. So mu naught by 4 pi times 2m divided by r cubed, where m stands for the magnetic dipole moment. So what do we know from here? We know that B is inversely proportional to the cube of the distance r. So B is proportional to 1 by r cubed, and that is the answer that we're looking for. So option E, 1 by r cubed, is the correct answer. Option D would be incorrect, because then that would mean the formula will be mu naught by 4 pi times 2m r cubed, which is not true. 1 by r square is also incorrect, because then the exponent on r is incorrect. Option B also falters because of the same thing. And option A is incorrect because, number 1, the exponent is wrong, and number 2, r is present on the numerator. R would be present on the numerator, which would make the formula wrong, the dimensions wrong. So therefore, option E, B is proportional to 1 by r cubed, is the correct answer. So that concludes this episode of Keam Prep. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, that is Brain Blitz Audios. Now, we'll be uploading a lot of Keam content on our playlist pretty soon. But in the meantime, if you want to do a quick revision of the chapters that are coming in this particular examination, then we've got you covered. We've had playlists on mind maps for grades 10, 11, and 12. So therefore, you can refer those for preparation. Their links will be provided in the description box below. And if you want to give us comments about what to teach next and how to prepare for the lessons next, then you can always use the comment section down below and inform us about it. We'll be happy to take your suggestions in mind. So until the next webisode, take care, stay safe, and I'll see you next time. Bye-bye for now.